Alright, so one night you're strolling down the chemistry department at Princeton, and you enter the famous Frick laboratories, and you see this ominous blue glow coming from the windows of the second and third floor. And while the image you have is indistinguishable from standard alchemy, it actually holds the key to all understood chemistry of cheaper medications, hydrogen synthesis, and manipulation of quantum phenomena. And it all starts with my favorite class of compounds, iridium-3 photocatalysts, which I like to call meta-catalysts, because these guys are usually coupled with another chemical catalyst in order to achieve a highly specific organic synthesis, hence the cheaper medications. And they're activated by an incoming photon of blue light, hence the blue glow. The problem is that this specific catalyst, which has a widespread use in the industry, has been reported to decompose in polar solvents. Specifically, we notice that these red fluorine atoms come off during the reaction, which begs the question, what is going on? And could it be that the compound we make and sell is not the one that's actually reactive during the solution? And so you do what you do, and you tell the computer as much information as possible on the compound to try and predict its behavior. Specifically, I tried first replacing the CF3 groups, which we know come off, with other possible moieties in the system. And by doing so, I noticed that most of my proposed solutions are not stable, and those that are don't agree with the experiment, with the exception of one. So now we know what may happen, but how exactly is it happening? And so you may now have the idea of stretching this carbon-carbon bond, and you tell the computer to keep track of the energy as it does so. And so now you have this plot of the energy of the system versus the length of the bond. And you do that for different states of this compound, specifically when it's excited, oxidized, or reduced. And you notice that when it's reduced, that is, when an extra electron enters the system, this carbon-carbon bond levels off in energy much quicker. That is, it becomes fragilized. It's easier to break it. And so now you may still be curious and you ask the question, okay, we know how it's happening, we know what may be happening, but you still want that intuition about what's happening. And so you tell the computer to keep track of the energy of each individual electron in the system as you stretch the bond. And you obtain this weird graph, which actually shows a descent trend if you look at it carefully enough. And so now you may consider plotting the image of this orbital, and as you do so, you notice that the thing that drops in energy is the thing describing the breakage of this carbon-carbon bond. And so by telling the computer to simulate the system you're interested in, you're able to sort of predict its behavior and develop this clear image of how it may actually be decomposing. So moving forward in my research, I intend now to, one, find a way of precluding this decomposition from happening, and two, finding a way of figuring out how exactly is this electron entering the system. I'm undercooked. Thank you very much for your time.